Hello folks, so in this video we're going to talk about how to create the equation of a quadratic. Now we have talked about how to do this before, but those are very specific cases. So for example, I know in previous videos we have talked about how we can use the vertex, the vertex and another point to create the equation, and that was, well, easy because we had the benefit of knowing vertex form, right? So we just use vertex form if we had the vertex. Cool. If we had the x-intercepts, I should also mention that the vertex itself would not be enough because you have no idea if it's oriented upward or downward. So you would need another point in addition to the vertex. Similarly, we could do the same thing with the x-intercepts. If we know the x-intercepts, we could use our factored form. Right there. Remember, x minus the first x-intercept times x minus the second x-intercept. Similar problem, though, to if we know only the vertex, in that if I only know the vertex, I don't know its orientation. And with the x-intercepts, you also don't know its orientation. So you would need to know another point. Now, what we're going to talk about in this video is the most general method, which will always work. Well, actually, assuming that you have 3 points. So if you had only 2 points, like the vertex and the second point, then you would need to use the vertex form or something like that. But what if I just had 3 random points? They weren't symmetric, so I couldn't find the vertex, and they weren't x-intercepts, so I couldn't use its factored form. In this scenario, where we only have 3 random points, it's actually going to be not too bad because we're actually going to look at it as a problem that we have done before, but we are going to have to resort to using our standard form, y equals ax squared plus bx plus c. So let's check out an example here. Alrighty, we're back, and here's our example. We want to create the equation of the quadratic function containing these 3 points. I should emphasize here that it is the quadratic function. There's only going to be one, just like how when you have 2 points on the line, there's only one possible line that can be made through those points. So as I alluded to before, we're going to use our standard form. So I'm just going to throw these points into that equation and just see what happens. Now, if you were in class yesterday, we had already kind of talked about how this is going to go. But remember, our standard form is just y equals ax squared plus bx plus c. Right now, we don't know what a, b, and c are. But I do know what x and y are for these 3 different points. So with the first point here, I'll just throw that in. So that'll be 32. That's my y value. Don't forget those mixed up. And I'll have a times negative 2 squared plus b times negative 2 plus c. I know usually we put our variables or our letters second, but I'm just going to literally plug these in as it's shown. Okay, now we have that. So I'll plug in this 1 comma 11. So I'll get 11 equals a times 1 squared, which is just 1, but I just want to show what we're doing. B times 1 plus c, like so. That's a 1. I apologize. I'm still getting used to writing on this little writing tablet thingy. Okay, and then now we'll plug in the last one. 67 equals a times 5 squared plus b times 5 plus c. Okay, so let's get rid of this now. Okay, if I clean this up, we'll get, let's see, 4a squared minus 2b, and we can do all that. But that's not the important part right here. The important part to notice is that I have 3 equations, and I have 3 unknowns here. I don't know what a, b, and c are. Remember, our goal is to figure out what they are. And so what I actually have here is a problem that we saw a couple weeks ago, where I have 3 equations with 3 unknowns. I'm really just solving a 3 variable system here. Just the only the thing you want to be aware of is that we're not finding, we have to think about what we're actually doing here. We're finding just values of a, b, and c, the parameters for our equation here in our standard form of our quadratic. Right there. We're not finding where these 2 points intersect or where these 2 lines intersect or anything like that. Although in essence you are, but that's not the purpose of the exercise here. And so we'll take a second here. I'm going to clean up these equations, and then we'll just go about solving it, just as a little review of how to solve a 3 variable system. Alrighty, so I've just rewrote those equations by kind of cleaning them up a little bit. And the nice thing about here is about when we go about our elimination, because elimination is going to be the easiest way to solve most three variable systems. You could use a determinant, which we didn't talk about, but you could definitely do that if you wanted to. And you could definitely go a substitution if you wanted to, but I think elimination is just the cleanest, so I'm going to go with that. Well, notice here, actually, it's really nice that in each equation, our c's will eliminate easily because they're just plus c. Again, that c would be the y-intercept of our quadratic anyway. And so what I'm going to do is I'm just going to take these first two and I'm going to subtract them. So I'm doing equation 1 minus equation 2, and that's usually how I'll notate it, right? Minus 2. I think it's always helpful to just number your equations. I'm not going to show the downward thing because we don't need to multiply them at all because they will cancel out c as is. So if I subtract 1 minus 2, equation 1 minus equation 2, let's see, 32 minus 11, that'll be, let's see, 21. 21 equals 4 minus 1a, that'll be 3a, negative 2b minus a b, I think that'll be minus 3b here. And then c minus c will be 0, which works out. Here, I'm just going to subtract the next two then. So I'll do, let's see, 11, sorry, not 11, equation 2 minus equation 3. If you wanted to, you could do 1 minus 3 as well. That would be totally fine. I'm just going to do it this way. So let's see, 11 minus 67, well, let's see, 67 minus 11 would be 56. So it would be negative 56 equals, let's see, 1a minus 25a would be negative 24a. And then b minus 5b would be minus 4b's, like so. Ready? Okay, as is, now we need to eliminate a or b. These equations are kind of messy, but, well, worst comes to worst, we could just multiply this one times 4, and then this one times 3, and we would eliminate b. But if possible, we should try to clean them up, make our lives a little bit easier. So notice on top, this equation number, I guess this would be equation number 4 here. And this would be equation number 5. Actually, let's put the numbers over here. Notice that in equation number 4, all their coefficients are divisible by 3. And so I could just fix this one by dividing by 3. Divide by 3. Leaving us with 7 equals a minus b. That looks a lot cleaner now. Similarly, in the bottom one, I could divide them all by negative 4. And it could be 4 or negative 4. I like to divide by negative 4 because I like to subtract my equations sometimes. Or add them. It just depends on how you like to do it. It doesn't really matter. You do what feels more comfortable to you. But if I divide by 4, negative 4, sorry. Negative 4. Like so. Then let's see, negative 56 divided by negative 4 would be, I believe, 14. Let's see, that'll be 14. Let's see, 24 divided by 4 would be 6. And then 4 divided by 4 would be b. Or just 1b, excuse me. Okay, I just double checking my work there. So now we have negative b and a positive b. So now I can just add these two equations together, and let's scooch over here just a little bit. Remember, this is equation 4 still, and it's just a cleaned up version of it. If I just add equation 4 and equation 5 together, well, let's see, 7 plus 4 is 14 is 21. 1a plus 6a is going to be 7a's total, and the b's will eliminate, leaving us now, if I divide both sides by 7, a is equal to 3. Whew. Really take your time in the beginning, folks, because if you mess up here, then it messes you up for the whole thing in the end. So now that we know, again, what a is, we know one of our unknowns, plug that into one of our two unknown equations. So I'll plug this into, it makes sense to plug it into equation number 4 because that's the easiest one. It's nice and clean. Into equation 4. So this will be 7 equals, a is now 3. 3 minus b. If I solve this, we should end up saying that b is equal to negative 4. Like so. And then now we can take this, and I'll do this last part in blue here. Let's make this a little bit smaller. Take this and plug it into one of the original equations. Let's zoom out just a tad. Oh, let me shrink myself. I apologize. You don't need to see me. Shrink myself down here. And now we're going to plug it into one of the original 3 equations here. Let's plug it into probably this one because it's going to be the easiest, I think. All right, so I'll plug that into equation number 2 there. A and B, so say now 11 equals A, which is 3, plus B, so it'll be plus negative 4 or minus 4, plus C, and if I've done this correctly now, then this should be 10. No, wait, sorry. 3 minus 4 is negative 1. 11 equals negative 1 plus C. And so that would mean C equals 12. Like so. And so our equation of our quadratic containing these points is, if we could put all the pieces together, y equals 3x squared minus 4b plus 12. And I just want to confirm that this is actually correct by pulling up Desmos, where I got these from. So if I throw in this equation here, we will have, here's Desmos. Let me pull this up so there's no distractions. Projector mode. You'll see, here's our equation, 3x squared minus 4x plus 12, which is what we got here. Oh, that should not be a b. Sorry, that should be an x. Oopsies. That should be an x there. And look here, the 3 points that we looked at were negative 2, 32, which is right here. And we can see way up here, negative 232. The other point, 111, which would be right here. Let me zoom in a little bit closer, not that one. This, not that one, right there. And 567, which would be way, way, way up here. Okay, so that is how you can take some quadratic with 3 random points and find its equation.